Hi there, this is Mrs McTaggart, and in this video we're going to be looking at a thing called quadratic problems. Now by this point, if you're watching this, you should have seen all of the quadratics topics so far, including solving quadratics by factorising and splitting them up equal to 0. These quadratic problems generally appear towards the end of a paper. They're not asked every single year, but they are very predictable the minute you see them, because part A is usually a show that question, and then part B is using that answer, factorising, splitting it up to find two values of x. So the moral to this though, the thing to take away is, even if you can't do part A, which for some people is the trickiest bit, you can still do part B. Part B is always about factorising. So let's have a look at the questions. Okay, so my first example, let's have a look at it. This one is based on area. It says, show the area of this room is given by A equals x squared plus 5x. And then part B says, given the area is 36, you have to find the value of x. So even if you can't do part A and you don't know how to do the area of this, it's told you that the area is 36, so that gives you something to replace A with, and then we'd take everything to one side and factorise a trinomial. However, we're going to do the show that bit. Now there's an easy way and a hard way to do this one. Depending if you want to split this into 2 or 3 rectangles, one definitely makes it easier, but I'm going to show you both, okay? So if you just split it into 3, you can work out the area of each individual box. So the first one is x by 3, so that's 3x. This one here is 2 by x, so that's 2 times x, 2x. And then this one here is x up and down, x left and right, so that one is x squared. So just by writing this up, that in the shape there, I know that my area equals x squared plus 3x plus 2x. And when that tidies up, I get that the area is x squared plus 5x. Now there was another way of doing this, but I think the other way actually makes it harder. If you only split it into 2 rectangles, the top rectangle would be 3 times x as normal. And the bottom one, where you could say that this total length along the bottom would be x plus 2. And you would say that this bottom rectangle would be x bracket x plus 2. And then when you times that out, you would get x squared plus 2x. And it would all still add up to give you what you've got. So we've done our show that. So part B, they've told us the area is 36, so we replace A with 36. Now these questions, 9 times out of 10, are all about taking everything to one side, factorising the trinomial. There is an odd occasion where it asks you to find your answer to one decimal place, which means it's quadratic formula involved instead of just plain old factorising. So I'm going to bring the 36 over to the right hand side, which will give me a negative 36. And then I should have what you recognise as a basic trinomial. So we're going to factorise it into 2 brackets. And we are looking for numbers that multiply to 36 and add to 5. So it's a combination of 9 and 4. And to make it positive, it's going to be plus 9 minus 4. Then you're going to put both of these brackets equal to 0. Some of you won't write this line. You might get into the habit of just going straight to the answer. And that gives us x equals negative 9, and it gives us x equals positive 4. Now, x actually stands for a length, so this one here is not possible. So we score it out, and you could write the word discard or ignore. I always just write that that's impossible. Okay, so it's impossible to have a length of negative 9. Just like in other questions, it's impossible to have a negative time. So the final answer here is x equals 4, and it's always a good idea to underline your final answer. Now just watch, because sometimes there's an extra bit to this question that once you find what x is, they'll maybe ask you to go get the length or the breadth or the area of a certain rectangle, but there's nothing to this one, it just wanted x, but we'll see it in another one. Right, example 2. It says to find n and hence the area of the triangle. All we've been told here is this is a right angle triangle. It's not your most obvious quadratic problem though. It might have a little show that actually, but the one I copied this from in a past paper didn't. And it's actually Pythagoras. Right angle triangles use Pythagoras. Now, to do this one, remember good old Mr. Pythagoras starts with this formula. So we're going to do the exact same. Remember, C is always your longest side. So we're going to write 3n minus 4. All squared. That doesn't look much like a squared. Let's fix that. Equals his short side squared. So I'm going to do the 2n plus 4 all squared plus n squared. Now if you need to, you write out all these brackets. I'm just going to jump down here so I've got a bit more room. So you write out your brackets twice. Sorry. Some of you might be able to square out brackets really quickly without doing this, but others don't, which is fine. Right, if we multiply these out, 3n times 3n gives us 9n squared. We would then have a negative 12 and another negative 12, so I'm going to cheat and put them together, which is negative 24n, and then we would have a plus 16 at the end. On the second one, we would have a 4n squared. We would then have a plus 8 and another plus 8, so plus 16n. I'm going to cheat and put them together. And then you would have a plus 16, and then your plus n squared. Okay, now the trick here is you want to take everything to the side that's got the highest power of n squared, which is to the left. So on the right hand side, I've got a 4 plus 1, which makes 5. So I'm going to subtract 5n squared, which takes me down to 4n squared. Then I'm going to do my letters. I'm going the plus 16 will become minus 16. So minus 24 minus another 16 takes me to minus 40. N. The 16s will cancel out there though, because I've got a 16 and then it'll become take away 16. So it's nothing, it's just equals 0. Now this is not a trinomial like that last one. This is a common factor. So if we take out a common factor of 4n, we will be left with n minus 10 equals 0. And if you break them both up, you'll have 4n equals 0. So n is 0. And you'll have n minus 10 equals 0. So n equals 10. Now, like the last one of these isn't possible, which is a 0. If n was 0, you wouldn't have any side on this triangle on the left-hand side. So I'm going to write that that is impossible. Remember, you can use other words. You can say discard. This isn't... You could just... I've lost my train of thought. Say discard, impossible, not valid, anything like that. So the final answer is n equals 10 for my length, but there was an extra bit to this question. It said once you find n, we have to find the area of the triangle. So what we're going to do is we're going to shove the numbers back in. So on this triangle, if n is a number 10, this would be 10 up this side, and the bottom would be 2 times 10 add 4, so that would be 24. And the area would be a half times base times height, so a half of 24 times 10. Well, half of 24 is just 12 times it by 10. It would be 120. Now, I really should have put units on here, which I didn't. So I'm just going to say that it is units squared. I think the question I'm copying was all in centimetres. So, good idea to underline your final answers in these questions, okay? Another one. So this is another style. This one is about the volume of a box. You know it's a volume from a box because you've seen a 3D box. Now part A simply says show that x squared plus 5x minus 24 equals 0. There's no mention of show that the volume is or v equals for this one like there was for the area, but the only bit of information is the dimensions and the volume of the box. So we're going to start with good old v equals LBH. We know our volume is 24. Our length is going to be x times x plus 5 times 1. So really the times 1 doesn't really count. So you end up with 24 equals x squared plus 5x. And it's starting to look really like their answer, but they've taken the 24 to the other side, so we're going to do the same. So we're going to do 0 equals x squared plus 5x plus 24. And that's us got part A. We've shown that. Doesn't matter if it equals 0 on the other side. That's perfectly okay. Okay, let's do part B. So again, if you couldn't do part A, you would start with the equation for part A, the equation they've given you in part A. That would be your starting point. And then it says to use part A, find the breadth of the cuboid. So they want us to find x. So we're going to factorise this. And I'm just going to put my equals 0 to the right because for some reason we all like it at that side instead. Numbers that multiply to 24 are 8 and 3. To get 5 is going to be positive 8 take away 3. Put these both equal to 0. Oh, helps if I put in the equals 0. And then we will solve them. So first answer gives you x equals 3. Second one gives you x equals negative 8. Well, of course, we know that x is a length. X cannot be negative 8 in this case, so we're going to discard that one and say that that is impossible. and then x equals 3. Now, I'm not done. You always go back and check this question. Question says, using part A, find the breadth of the cuboid. Now, the breadth of the cuboid is this one here. If you think of your swimming pool, this would be your breadth and this would be your length. So I've actually answered the question. The breadth is 8. Had they asked you for the length, however, you would have something else to do. So the breadth is 8 metres. But had they asked for length, and there's no harm in putting it in, you could say that the length is 8 plus 5, which is 13 metres. Now, the question I've probably stolen this from did give us a wee bit more information up the top and would have said that the breadth is x, the length is x plus 5, and so on. So that's that one finished. So there's a different style talking about volume. So a lot of them seem to be taking on some like first year maths knowledge about area and volume of basic shapes. Here is my fourth and final one. They've asked a couple like this about paths before and they're a wee bit trickier. So let's have a wee read. We are told that a rectangular lawn has a path 1 metre wide on 3 sides as shown. So the white bit is a path, the green bit is a grass. The breadth of the lawn is x, which is shown. It says the length of the lawn is 3 times the breadth. So this green bit here is 3 times the breadth. So it's safe to say that that bit is 3x. It says the area of the lawn equals the area of the path. Show that this, right? So I'm just going to write that down. They've said that the area of the lawn equals the area of the path. Now the area of the lawn is really easy. It's just 3x times x. So that is 3x squared. Okay, so this bit here is 3x squared. To get the white bits, we're going to split up this path into a series of rectangles. So I'm going to do some lines in here. If you want, we can keep this really simple and I can make loads of little rectangles. Now the path is 1 metre wide all the way around. So this first little bit is going to be x times 1. So that's just x. Same on the other side, it's going to be x times 1. So that would be x. Along the top, it's 1 metre wide and we're timesing it by 3x. So that would just be 3x. And these little ones up in the corner are just 1 metre by 1 metre. So these are just 1 metre squared. So the total area of the path would be 3x plus x plus x plus 1 plus 1. And then we'll tidy that up. Well, that would be 5x plus 2. And if you have a look at what I've got compared to what they've got, all they've done is they've taken everything to the left-hand side, which we are going to do. So that becomes negative 5x and negative 2. So that's part A done. Part B is hence find the length of the lawn. Okay, so the length of the lawn is a bit that says 3x. That's what they're trying to find. So we're going to factorise. So this is part B. Again, if you couldn't do part A, you start with this expression that they've given you as to show that, and you put it equal to 0, and you factorise. So numbers that multiply to 2, the only options are 2 and 1, and I'm reckoning it goes this way, because 3 times 2 is 6, and 1 times x is 1. To make them minus 5, then the negative has to go there and the plus there. Now that might not be the way you've been shown factorising. You might have been shown that you do 3x and x, do your cross multiplying. If I put the 2 there and the 1 there, well, that'll give me a 6, that'll give me a 1. The minus went with the 2, the plus went with the 1, and then you circle your brackets. That's exactly what I've got as well. There are so many methods of factorising. If this isn't the way you do it, pause the video and go try it your way and check you get the same answer. Then what do? Well, we break these up equal to 0. So 3x plus 1 equals 0. So hopefully you're getting the catch now that all these questions are about factorising everything to one side equal to 0. Right, this one is going to give me negative 1 over 3. And this one is going to give me x equals 2. Now, it can't have a negative length, so I'm going to score that one out and write impossible. And then I know that x equals 2 is the answer I'm using, but the question said find the length of the lawn, so I'm going to write length equals... Now, the length was the bit that said 3x, so it's 3 times 2, which is 6, and we're talking metres, so I'm going to put my units in. So this is just a taster of some of the questions. Remember what I said, that part B could involve quadratic formula if it talks about rounding at all, but generally it is maybe plugging in a number, everything to one side, factorise, break it up, rule out an answer. That's kind of like my wee mantra of the steps we do. And the more you do, the more you see. But remember, these are hard questions. They're right at the end of quadratics. Sometimes we take a gamble and we don't always teach these to classes. So if you're watching this as a wee bit extra, well done to you. But the clue is part B is easy pick up marks, even if you can't do part A. Thanks for watching.